Hello everyone, I'm Sanat again from Aries Education. So today we're going to be talking about topic 1.2 from the APCSA curriculum. So again, I'm going to be using the IntelliJ IDE, which I'll also link in the description. So topic 1.2 deals with what are called variables. So what a variable is a variable contains information and data for us to use later. So this could be text, numbers, and all sorts of other information. So first, how do we create a variable? So the first thing we have to do to create a variable is to say what type of variable it is. So in other languages, uh, you don't have to specify the data type, but in Java you do for every variable you create. So what is a data type? Data type is something to tell the program what type of information we're storing. So it could be a number, a word, true or false, or some any other value. So first, we're going to talking about numbers. So what the number data type is, it's called an int. So it's short for integer. So this is used whenever we want to store any form of integer values. So -1, 0, 1, 2, 3, whatever integer values, so any non-decimal values, can be stored in an int primitive data type. So the next thing we have to do when we create our variable is to give it a name. So I'm just calling it number1. So one thing to note when you create your name is that you can't put a space between it. Uh, if you put a space between the different parts of the name, the Java will think that it's two different things. So it won't recognize that it's one name. So because you can't put a space, one thing that people do that they would put a underscore, or if they were trying to say number1 spelled out, they would put the 1 as a capital, which is called camel case. So you put your first letter of the first word lowercase, and the first letter of every other word uppercase. So this would be number1. So next we need to give it a value. So the way we do this is we create an equal sign. This says the value that's attached to the number1 variable will be whatever is after the equal sign. So I'm just going to say that it's 6. And again, because it's a statement, we have to put our semicolons. So what this piece of code that we have right here does is it says a integer value that has the name number1. Give that value this give that number a value. Give that name a value of 6. Okay. So this is the thing. If we try to give it earlier, I mentioned it's only works with integers. If I try to give it a decimal value, it'll give me an error because integers cannot handle decimals. So because what we have to do is we have to change the data type that we have. So I'm going to put a comment so that we can keep track of all the data types. So the way we create comments is we put 2 forward slashes. So we say anything that we type in a comment is not read by the code at all. So we can type whatever we want and the program will just skip over it. So an integer value, so -1, 1, 0, 1, is stored in an int, right? So for decimal values, they're actually stored in what's called a double. So a double is like an integer, but it can store any number. It can store integer values, it can store zero, negative numbers, decimals, anything. So any other number values are stored in doubles. So the reason why one of the reasons why you might not want to use a double instead of an integer is that when you create a variable, it takes memory in the computer, right? So what this does is that it takes the memory and it gives the memory that value. It creates a memory address and gives the memory address that value. One thing to note is that integer, double, and other things that we're going to talk about today are called primitive data types, right? They're primitive because when the program gives the value in memory, gives a variable that value in memory, it directly gives that exact value. For other data types we'll see in the future is that it won't actually give that value. It'll give like another address to another different memory. So these primitive data types, right, all take up a different amount of memory. So one of the cons of using a double is that it takes up more memory than an integer because it's able to store more different types of numbers. So that's our integer number. It's our numbers, and next we're going to talking about true and false, right? So how do we know whether something is true or false, right? So how do we store that information? Well, we store that information as what's called a Boolean. So a Boolean is something that can be true or false. So true or false is stored in a Boolean. So a Boolean, again, I'm just calling it bool. You can store anything true or false. So you can say true, or we can say false. So this can be useful in if statements, which we'll talk about later, where you can say like, if this boolean is true, then do this piece of code. But if this boolean is false, then do this other piece of code. So this can be very powerful in writing complicated programs, and will be very useful to us soon. So these are the three main primitive data types that we'll be talking about in this course. There are others, but they are not as relevant as these three main ones. So last time we talked about print statements in how we can print string literals out using quotation marks, right? So again, we one thing that we can do with primitive data types is that we can also print out those instead of strings. So for example, if we create a print statement where we do system.out.println and put the parentheses, we can just put the value, the name of the variable, and it'll still print it out. So if you run this program, it'll say false, right? Because that's the value attached to the boolean. Or in another case, if we say int num is equal to 0, and we print out the num, it'll print out 0. Oh, yeah, it'll print out 0. And we don't even have to put a variable. We can just put the value right into the parentheses. So let's say 3.2, and it'll print out that value. So one thing that you might have noticed is that if we can express these integer and boolean and double variables as literals, right, putting them without a variable inside the parentheses, then what about the strings that we talked about yesterday, the string literals? So as we saw yesterday, we can print out these words without creating a variable. So what would the variable for that look like, right? Because they don't fit into any of our three categories that we have so far. So what we have here is called string, right? So strings are unique that there are not primitive data types, but we use them a lot. So a string has a capital letter, which shows that it's not a primitive data type. And if you saw before where the primitive data types that we had were highlighted in orange, strings are not. That shows that it's not a primitive data type. But creating a string just goes like any other variable. We just say string, give it a name, so let's call it name, set an equal sign, put a value. So in this case, the value would be a quotation mark, something in quotation marks, and we end it off with a semicolon. So we can just print out the string name, and it will be printed. So one thing that we can do is we're going to talk about one of the first keywords, right? So yesterday we discussed these keywords that we had in front of the main function, and I kind of touched on it and saying that we're going to talk about in the future. So we're going to talk about one of those keywords. It's called final. So it doesn't appear here, but it's something that's unique and it's related to these ones. The final. So what does final do? So normally when we have a variable, right, we can just edit the variable's value as much as we want. So we can say name is now equal to yes, right? Name is now equal to yes instead of hello, and when we run it, it won't print hello, it'll print yes. So it goes in the order of the lines. So if you put something below another line, it'll that whatever you do, or the value set will overwrite the value you put before, right? But if we put the final keyword before the string, it'll give an error. That's because what the final does is that it tells you that this value cannot be changed at all, right? The value you set initially cannot be changed. So it'll give an error whenever we try to change it. So this can be useful when you know that there's not a value that you can change, and you're making sure that you never change it at all. So this is a brief description about the data types and the primitive data types and how we can use them in different ways. In the next episode, we're going to talk about doing operations on the data types and doing arithmetic and different stuff with numbers. So thank you for watching and have a great day.